So now the Phelos instrument will measure the angular dependence of OLED emitter film, where we excite with blue light, and the green is the photoluminescence that is measured versus viewing angle.
So right here with Fluxim. Hello.
Yes, my name is Beat Ruhstaller. I'm the founder of this company. We have targeted the OLED industry and research community worldwide, and this is our newest instrument that helps to improve OLED devices and OLED materials. We have started with simulation software in the past.
So why are we simulating a flexible OLED?
Because this is cutting edge. Displays are going to be flexible, and all these new display pixels, they need to be optimized. The layer sequence of the OLEDs need to be optimized. We can simulate the electrical property of the OLEDs, but also the light emission, how much light is coupled out or is trapped in the substrate. And we can do angular measurements. This data shown here is exactly taken from this instrument next to it. These purple data points are measured, and the green line is the simulation. And thanks to the good agreement, we can get the material parameter, namely the molecular orientation of the emitter film is a key optimization parameters. The more horizontal the molecules, the more light outcoupled to the air.
So what are we looking at right now? What's happening? What's it turning and measuring something?
Yes, that's the blue LED, UV blue kind of that you see is exciting the organic film. The organic film emits green light. That would be the material in an OLED display of the green pixel material. And here it's just to get this data that we just saw in the product flyer. The angular spectra are measured, and the angular spectra are then integrated, and in the end we plot the S and P polarized emission intensity of the OLED film, and by this we can determine the emitter orientation by doing a simulation with the SID software that gives these lines that fit the measured data. And so it's innovative that now this instrument can do optical excitation as well as electrical excitation.
So what each part is doing right here?
Right here we have a sample holder stage with a macro lens.
So it's holding a sample of an OLED display?
It's not a complete display. Basically it's an emitter layer, a layer of an OLED. We see here there's a glass. It looks transparent, but you just saw before, if we illuminate with the blue light, then it will luminesce in green. And this transparent layer is part of an OLED pixel in the end.
So this is part of an OLED display or pixel? What do you say?
Yes, this is a large area film. This film that looks transparent will then be used in an OLED. This is now a research OLED pixel. There are a few OLEDs here inside, just 4 of them. It's not a high resolution display, it's just made to improve and optimize an OLED stack. OLED stack means there are thin films of OLED materials that make up the OLEDs. And instead of this film, I could also place the OLED here and directly excite the OLED. Instead of doing an optical excitation, I can also do electrical excitation called electroluminescence.
But which part is the OLED?
It's not so easy to see because there is an encapsulation glass and a metallic cover. Usually if I have an electrical contact, then the light would come out from this side. But I would have to remove this sample and then place the OLED here, and then make sure to contact the electrical pads. But now, I would need still to change the vertical position here in order to touch these pads.
So who would be using this?
We have customers in the OLED industry, the big players from Korea, in Japan, in China, and everywhere in the world.
So how do they put their samples in there or something?
They have to make in their own labs. They are making such research samples in order to play around with new chemicals that the suppliers of the material give them, and they need to select the right materials for highest performance OLEDs that are stable, that are highly efficient. So we're giving enabling tools to the industry.
So this is the Phelos.
Phelos, yep.
Phelos. And this is for these kind of companies to buy?
Yes.
And they put in their labs?
Exactly, in their research labs to have so they can prepare the next generation of OLED displays.